75 million years ago, the landscape of North America was a labyrinth of winding rivers and lush subtropical forests. Within this emerald world, a unique silhouette breaks the dense canopy line. This is the realm of the Corythosaurus, a creature whose very name evokes the imagery of ancient Hellenic warriors. Yet its helmet was forged not for war, but for something far more complex. Standing nearly 30 feet long, this hadrosaur was a masterpiece of herbivorous evolution. Its body was built for endurance, but its head carried the weight of a biological revolution in communication. The most striking feature of Corythosaurus is the tall, semicircular crest perched atop its skull. To the early paleontologists who discovered it, this structure appeared as a decorative, perhaps purely visual crown. However, as we peel back the layers of fossilized bone, we find that this crest was not a solid ornament. Instead, it was a complex network of hollow, winding passageways. These internal conduits were extensions of the nasal cavity, spiraling through the bone in a sophisticated geometry. This was not just anatomy, it was a biological instrument refined by millions of years. To understand Corythosaurus, we must look beyond its physical form and consider the air that once vibrated through these chambers. We must listen to the whispers of the deep past and its sounds. In the world of the late Cretaceous, visibility was often limited by thick vegetation and the shifting mists of the floodplains. Sound, therefore, became the primary currency for survival and coordination. The Corythosaurus utilized its crest as a resonant chamber, much like the body of a cello or the piping of a brass horn. Each breath could be transformed into a distinct signal. These signals were likely low-frequency booms, capable of traveling vast distances through the humid air. They were the tectonic rumbles of a living communication network across the ancient floodplains. This was the birth of an intricate social language. Through these sounds, a Corythosaurus could convey identity, social status, and even emotional states to its distant kin across the canopy.
Imagine a herd grazing near a riverbank. A single individual detects the scent of a predator on the breeze. It does not just run, it speaks to the collective group. A short, sharp blast from the crest acts as a biological alarm bell that ripples through the herd. Within seconds, the entire group is alert and moving with unified purpose. This level of coordination suggests a high degree of social intelligence. The Corythosaurus was not a solitary wanderer, but a participant in a structured, vocal society that relied on sound. The diversity of crest shapes among hadrosaurs suggests that sound served as a specific dial tone for species recognition. Every species had its own unique, recognizable frequency to prevent confusion. While the Lambeosaurus might produce a sharp trumpeting call, the Corythosaurus likely emitted a more rounded, hollow resonance. These were the various dialects of the late Cretaceous wilderness. Sexual selection also played a crucial role in the evolution of this anatomy. Larger, more resonant crests may have indicated a healthier or more mature individual to potential mates during courtship. During the breeding season, the valleys of ancient Alberta would have echoed with a cacophony of these low-frequency calls. It was a sonic battlefield for reproductive success and dominance. Yet, the crest was more than a megaphone. It was also a visual signal, a vibrant billboard that could be seen from a distance, perhaps colored with vivid, attracting patterns. This dual-purpose organ, both visual and auditory, represents a sophisticated evolutionary strategy. It ensured that the Corythosaurus was seen and heard in a crowded, dangerous, and competitive world. The predators of this era, such as the formidable Gorgosaurus, were masters of ambush. Detecting them early was the only way for a defenseless herbivore to survive the day. By evolving a system of long-distance communication, the Corythosaurus effectively extended its sensory reach. The herd became a massive distributed ear,
listening for the soft footsteps of approaching death. When we examine the fossilized skin impressions of Corythosaurus, we see fine, pebbly scales. This reminds us that these were real animals with physical textures, vulnerabilities, and complex lives. Their limbs were robust, capable of supporting multi-ton weight as they transitioned between bipedal movement for speed and quadrupedal movement for steady, rhythmic grazing. The beak of the Corythosaurus was perfectly adapted for cropping tough vegetation. Behind this beak sat a battery of hundreds of teeth, ready to grind plant matter into fuel. This efficient digestive system allowed them to process vast quantities of fuel, supporting the metabolic demands of their large bodies and active, highly social lifestyles. But it is the brain-to-crest connection that remains the most fascinating. The neural pathways required to process and produce these complex sounds were likely quite advanced for their time. Paleoneurology shows that hadrosaurs had relatively large brain cases compared to other dinosaurs. They were the intellectuals of the herbivorous world, driven by social interaction and communication. Their world was one of seasonal migrations, following the growth of ferns and conifers across the vast coastal plains of the western interior seaway that split the continent. As the sun set over the horizon, casting long shadows across the marshes, the Corythosaurus would begin its evening rituals, huddling together for warmth and collective security. In these quiet moments, the crests might have produced softer, more intimate sounds. These could have been contact calls, maintaining the bond between mothers and their vulnerable young. The juveniles were born with only a small nub where the crest would eventually grow. Their voices were likely higher pitched, changing as they matured into the deep tones of adulthood. This ontogenic change in the crest meant that a dinosaur's voice matured alongside its body. A Corythosaurus literally found its voice as it grew into its role within the herd. The fossil record gives us a glimpse into this progression, showing us how the hollow chambers expanded and coiled as the animal reached the peak of its sexual maturity. It is a rare privilege to see the evolution of a language written so clearly in bone. We are looking at the fossilized remnants of prehistoric conversations frozen in time. The extinction of these magnificent creatures marked the end of a unique acoustic era. The forests fell silent, and the low-frequency rumbles vanished into the earth for eternity. Today, we use CT scanners and computer simulations to breathe life back into these silent structures. We are attempting to play the instruments of the dead through technology. When researchers recreate the sound of a Corythosaurus, the result is a haunting foghorn-like blast. It is a sound that bridges 75 million years of separation between us. It reminds us that anatomy is never just about physical survival. It is about connection. It is about how an organism interacts with the consciousness of its peers and environment. The Corythosaurus teaches us that even in the brutal struggle of the Mesozoic, there was a place for beauty, for song, and for the sharing of vital information. Its crest stands as a monument to the power of communication. It is a reminder that being heard is as vital to life as being fed or protected. As we stand in museums looking up at these towering skeletons, we must try to hear the echoes of their ancient calls in the stillness of the hall. The helmet lizard was more than a relic of a lost world. It was a pioneer of the vocal complexity we see in modern birds and mammals today. We are part of a long lineage of vocal creatures, and the Corythosaurus was one of our most successful predecessors in the art of the sonic signal. Their story is a testament to the creativity of evolution, turning a simple nose into a cathedral of sound and a tool for social cohesion and survival. In the final analysis, the Corythosaurus shows us that anatomy is not just a container for life, but a medium through which life expresses its presence to the world. Every curve of the bone, every hollow space, and every ridge on its skull was a letter in a grand biological alphabet that we are only now learning to read. The study of this dinosaur continues to challenge our assumptions about the inner lives of extinct animals, revealing a world far more vibrant than we once imagined. As we close this chapter on the Corythosaurus, we carry with us a new appreciation for the silent music of the fossils and the language of the helmet lizard.